is Kavita, the host for today's session. I hope everybody is able to hear me loud and clear. If may I get your confirmation as yes on the chat window, please. Thanks for the confirmation. Thank you, Aditya. Excellent. So let's go ahead and begin the session. And before I begin the session, so I just have a quick update for you. So participants, tomorrow we have a project mentoring session, and which would be handled by trainer Shubham itself. And this is actually scheduled at 4:30 p.m. IST. So share the registration link on the chat window in a couple of minutes. I would request you to kindly plan up and make sure you attend the session and understand how the projects has to be worked on. And in case if you have any kind of questions, please feel free to reach out to Shubham and he can definitely help you during the session. And also, kindly submit within 30 days of your course completion so that it will be easy for us to evaluate and provide you the project completion certificate. If you have any kind of questions, free to ping me on the chat window so that I can assist you accordingly. Okay, let's then begin the session and let me quickly pass on the access. Shubham, welcome to the session.
How are you?
I'm doing wonderful, Shubham. How about you?
Thank you so much.
Yes. Shubham, you're the presenter now. Over to you.
Yeah.
Thank you much.
Good morning to everybody. Let's start today's session. Last time we learned a lot of things which are very important for today's session. Through hypothesis testing, we understood what we can do with the help of t-test, what we can do with the help of F and then chi-square test. And after that, we also understood what is correlation, how we calculate correlation coefficient, to discuss regression. So we discuss regression. I will quickly weave together everything. Hypothesis testing will be used in regression as well. So you should be knowing what. So if we everything together, you will get to understand that test and t-test are formed one sample and two sample only. You need to compare a significant difference between the two ratios or not. Z-test or t-test depending on one thing. Whether the distribution of the population is known or not. If the standard deviation of the population is known to you, then you go Z-test. And a practice where the standard deviation of the population will not be known to you, or t-test. Okay. That scenario test, we understood this thing that if we are going for multiple t-tests, which we have to perform if we are going for more than 3 samples, more than 2 samples, I mean 3 samples, 4 samples, where we need to compare multiple populations and where we need to come up with a conclusion like there is a difference between population A, population B, population C, population D. So in that scenario, multiple t-tests are not conducted. Instead of multiple tests, we go for ANOVA, analysis of variance. In ANOVA, we compare the bottom variance and within column variance. We take the ratio of that is called F ratio, and from F ratio, from statistic we find out the p-value, and finally we make a decision whether we should reject the null hypothesis or accept the null hypothesis based on the comparison of p-value with the significance level. If the p-value is less than significance level, we reject the null hypothesis. Otherwise, we don't reject the null hypothesis. That is what we did F test. So that was for comparing population on variable of interest. That variable of interest used to be a continuous variable. When we need to cases where there is a categorical variable, factor variable, and these tests will not help you, cause in those kind of scenarios you have to go for chi-square test. Test will help you to the significant association between the two category variables or not, if two categorical variables are independent or not. So test you can do using chi-square test. That to you how we actually find out these and expected frequencies, how can find out the ratio to you. You have one table of expected frequency, you have one table of observed frequencies. From those two tables you actually derive the of chi-squared, and from chi-squared value you again the p, and from p you can decide whether the two variables are independent or not. What we have done basically so far, and after that we uh, start doing correlation, which is again important. I told you how correlation between the two variables is established, and how you measure the extent of association between the two variables. I know that correlation coefficient is something which is used to find the extent of association between the two variables, two continuous variables here in this case of correlation. And the value of correlation coefficient lies between -1 to 1, 0. Be close to +1, it simply means that the two continuous variables which are under our purview, they are very positively correlated. If towards values, I mean to say, if one is increasing, also increasing. If one is decreasing, another one is also decreasing. That correlation. If the value is -1, they are highly negatively correlated. Is going for higher values. If one is increasing, other one would be decreasing. If one would be decreasing, other one would be increasing. So it will be a reciprocal relationship. That's we all discuss this thing with the help of the scatter diagram, that house prices case study only, to make it more clear. Okay, and that the price and lot size have very good correlation. Price and age had negative correlation. The strength of correlation, value of correlation coefficient was not very close to -1 in case of age and price. Fully correlated, but the correlation coefficient was small in value, and you it did at the time that yes, they are moving in opposite directions, but the strength is weak. Okay, so we saw that thing on the graph as well, how the strength is weak. able to depict this thing from the graph itself. Uh, those two variables are actually moving along each other. So now we can go for a regression. We can start our discussion for regression. Any question from the previous session or whatever you want to uh, ask about? No sharing any screens so far. It's only discussing about what we have gone through in the previous sessions. Because this time, when I'm about to discuss one technique, regression, important for me to collect all the small things which we have learned in the past days. Okay. Now, screen. I'll do again. Discuss this thing. Uh, show it to you again. When I discussed that was the last piece. So that to discuss with the correlation that view. That is something we have yet to discuss. I know. If you put that file into your R environment, that CP file which I gave to you, put that file just. So we'll put that file. In that file, there are two variables. Progress school. Since we have been using this file since ages, this file is really pretty familiar to all of you, all of us. So you see school and program. These two are categorical variables. There are two schools and programs. I want to check here whether these two variables are associated among themselves or not. Whether the choice of program uh, schools or not. That I want to check. Okay. So check thing. Use chi-square test, CHISQ dot test. For variable will mention program, assigned variable will mention school, and run it. You'll see the value chi-squared is calculated, degree freedom will be given to you, and then P has been calculated here. Okay. Basically, chi-squared value is calculated using that formula x of chi-square uh, of frequency minus expected frequency squared divided by observed frequency, and then you take the sum of that, issue that formula as well. But you need not to go through the formula as such. The concept is important, and keep that concept in your mind. Okay. But I have to look at the p-value. That link uh, this is so I'm sharing this again in case you people have not. I believe a few must be having it already. But you don't have it, I have shared that link as well again. Question. Okay, so now move to action. Where to go? Just click. Uh, and understand how to find out the correlation coefficient. We can use COR function for that. We have the variable which we want to compare. Suppose that variable is math 1. In my math 1, math 2, in your case it will be math and science. So HP dollar math dollar science. You can calculate the correlation coefficient. The code in the chat box. Check what is the correlation coefficient coming out to be. Or something to correlation coefficient between read and write. Just you can put 0.630. Thanks, Anta. Yeah, right. So to find out the correlation coefficient for multiple variables and you want to compare those coefficients, how would you go about that? So house prices. So let's this as well. HP, and then you can mention the column numbers. Can concatenate them. Want to find out the correlation coefficient between 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So you like this, where different correlation coefficients reference. file as well as you import. Using this file for regression as well. To import, because time and again. How different correlation coefficients. Please package core plot if you want to know some visualization with current coefficients. So it's a visualization package. Solar PLOT. So this core formula, whatever are the results that I'm saving here in text, and then I'll cut exact and send you a good visualization which you can feed people. So the degree association, whether it's positive or negative, has been assigned. Right? See, and this is scale. The bubble and color of the bubble uh, this, okay, that And how many not able to do? Before you are able to do. So you see here, I'm doing here on the I have these values. Between price between the same variables, we have the highest correlation possible, which is quite obvious. So allied diagonals. So as you will see all across one. Okay, uh, above the diagonal and below the diagonal, those values are same because the correlation between living area and price would be same as the correlation between price and living area. The change does not change the correlation coefficient because it is the association between the two variables. It does not matter who comes first. Okay, so you see here the the coefficient between price and age, it is negative, but the value is 0.36 in negative. So that's shown here by veiled orange color. The scale here on the right hand side. The coefficient between price and living area is 0.77, which is shown here with blue, and it shows you uh, is the degree. Considering here four attributes: price, living area, lot size, and age. So four here, and you see the if you compare price, you would see lot size, price, and these two are positively correlated. Lot size is again 0.15, which is very close to 0 instead of 1. So they are positively correlated, but the strength of relationship is very, very okay. A dilute correlation coefficient now. So you can see here the color as well accordingly, size as well accordingly. Okay. Nagesh, to answer your question, the support coming here. Can you let me know what is support? You're right. Because it's a different term which see a definition into this class only when we'll be learning market basket analysis. Oh, that's fine. Okay, so question we wanted to discuss. Anybody, if you have any question, let me know. If you want me to draw out of it is the price and living area are highly correlated. So if area will increase, is increase. That is something which we can draw out of this. Okay, we will be able to draw a lot of things as a conclusion, which you might be anticipating, and I'll be discussing in another minute what all we can draw, which is not able to do using correlation. It only gives you the association, dissociation. So let's discuss what it is able to do for you and is not able to do, and will do to derive, to achieve the those questions which correlation is not able to answer for us. After learning correlation, yeah, Praveen, please go ahead. What is question meaning of? Okay, so here mining multiple variables. So for you are mentioning two variables by commas, view the correlation coefficient for the two variables. But if you want to is multiple variables in a go, if correlation coefficients of multiple variables, this is the way you can go about. So 8, 9th and 10th, they are the column numbers. Okay. We have this data. I have discussed this thing with you earlier as well. That we have this data of house prices near New York suburb, and if I want to come up with an estimate, how come up with that estimate? That question which we did in estimation. After those examples, I told you let's do it for a data set, and then I asked you to estimate of New suburb. Yeah. So if you don't remember, please collect from your memory, because that is something very important which will again come back. Okay. So time I told you that you better forget about uh, rest of the variables. You only consider the price variable, but here you see some other variables also here. Like you have lot size, you have living area, you have age, you have number of bathrooms, bedrooms, different things. Calculated the range of values depending on the confidence interval we want to go along with. Yeah. So don't we have learned, okay, of those things for these techniques like regression. So since we have these variables and we have started getting into this discussion that if living area is increasing, also increase. If living area is decreasing, price will decrease. If age will increase, price these. But yes, the age is increasing in general, price will decrease. For older houses, the price will be. That is what we can derive of it. Quite human. You would now start expecting more. So just like to see if you have suppose living area equal to X, what will be the value of price? I mean, would like to do some prediction now. If no living area, how can you predict the value of price? Is one question. So first, we are not able to answer with that correlation. You can see here is the answer uh, of price other parameters. Which you are not able to do with the help of code or the help of any other technique which you have learned so far. So we learned so far hyper testing. You can check your assumption, your hypothesis. You can compare multiple populations. Okay, that's what you can do. You also learned chi-square test, in which you can the degree of association of character variables. You have learned correlation, but none of those techniques which you have learned in the past is able to help you answer this question. How will you predict the price if you have values of lot size, if you have values of age, if you know how many number of bathrooms, bedrooms are there, whether that house has a fireplace or not, if you have all that information, how do you go about predicting the price is a big question. We're able to answer using correlation. Okay. So would I go out this? Another is, if is changing from x1 to x2, how okay. Basically, you want to see if you are making some changes in living area, you are making some changes in other parameters which are affecting your uh, interest, which is price. Okay, how you go to incorporating those changes in the price variable, in the variable of interest, if other parameters are changing, that you cannot achieve, that you cannot obtain using correlation for sure. You need some other technique, you need some other methodology, some other tool to actually get into answer kind of questions, and that technique is regression. Go through any book, the book which I have suggested you, and look into the history of what regression is and how it started. Very fascinating. This started from to predict the height of the children from a height of uh, okay. So those things are there. Regression, this name, how that name came up. So you can go for those kind of uh, uh, is uh, that's a different thing. but let's discuss about what a regression is. So in regression, basically what we do, we try to find out a relationship between deep variable and other independent variable. Now, what are independent variables and what is a dependent variable? So if you look at price here, we are considering price to be affected by living lot size, age, number of bathroom, number of bedrooms, fireplace, these kind of parameters. Price here is depending on rest of the parameters. Price as a dependent variable, rest of the variables as independent variables. Dependent variable and rest of the variables as independent variables. And we try to find out the relationship, a relationship between variable and independent variables. Variables are also named as regressors. These are called as regressors. Lives age. The independent variables in some books you will see they are also called as pairs. So dependent called as regressors. As pairs. These naming conventions, because you should not get confused that I have not learned regressors. What is regressors? We you to predict the value of price. Back to that question. Let me open file again. Draw shape and show you again. So start with a very basic thing. I mean, I will not be taking up any variables. Let's take one dependent variable and one independent variable. One variable, let's say independent variable, let's say lot. Okay, out the relationship between the two variables. It's very basic. This methodology is called linear regression. We are trying to find out a linear relationship between price and lot size. That's why linear regression. Since we are taking up only one variable model, it is simple linear regression. Your location. It will be dependent variable and independent variable. What if I am taking up for our modelization, that is called simple Okay. Let me gonna do. It's uh, I need your attention here. So for living and for values, I'm giving the values price. Pretty much giving a graph. So this is how variables are actually read in this data. Values of living area, you have in values of price. Okay. What is our objective here? Our objective here is to find out a relationship between price and living area. That is our objective. So relationship, if you talk about the relationships, functions and all, if all living area y, sorry, x, let's x as y. Looking forward to dive y equal to dive. At the outset, I told you we are actually looking forward to a linear relationship between the two weights. So that actually look like this. Or it's beta only, beta not beta 1 into x. The relationship would be like this only. So naught plus beta 1 into living area. That would look like this only. Price is equal to beta naught plus 1 into that what we will see. Anyone? What is beta naught and beta 1? They are knowns. Would be only. Do you agree or not? The equation of a straight line in seventh standard is equal to mx plus c. Do you remember? M used to be slope and c used to be intercept. Beta 1 is the slope and beta is the y-intercept. Good question, Martin. How arrive at as linear? So we can go for any other equation as well. If you look at this trend, it seems like linear one, but it will be curve as well. Some other curve it might be like to make it easier at the start. starting with linear regression. Okay. You can later on a polynomial equation as well. Okay. Looking at this curve and looking at some other values as well. But it is hard to keep the things simple. Starting off with linear regression. Not able to understand so far. So all you have understood so far. Now the problem is can't draw any line by looking at it. We can't any line. Instead of line, you want to create some other equation. X is equal to what? X naught plus beta x plus b2 square. That you have like this as well. In the case, this is an equation of a parabola. It's second degree equation. The equation for parabola will get. So you are getting a parabolic equation or a linear equation. You will get a curve. That might be a straight line. That curve might be a vertical. Something like this. In all of these cases, you can repeat here that you would not be able to get all variation. It's possible for you to get all the variation. I may you are creating a straight line. So a straight line. What should happen? All these points should be on the straight line, on this straight line, which will never be the case. So what you would try to find out a straight line which can present the relationship between y and x the best possible way. Okay, and you would also come up with the error part with the uncertainty part. I mentioned that thing while predicting that the value, and you can expect the prediction by the values. This is how you go out prediction. In case you want this line to repeat all these points the best possible way, not. How many of you are not able to understand this concept so far? Because after half an hour's discussion at 10:30, if you will ask me to repeat again, it will be difficult. Well correlated? No, it is not. It is not a prerequisite. Be high correlated, they might not be. Relationship. Actually, Martin, how we can define well or not well? How we can define the very highly correlated? They are highly correlated. They are less correlated. So they relate it. We would like to find out the relationship between them. Whether we are able to establish that relationship or not, that will be decided later on. We have some parameters which will let you know. So that's something which we always do in statistics and analytics. We come up with a parameter to answer our question. To answer a question whether the relationship can be developed or not, you are some extent. But if you will decide on the basis of correlation coefficient, the right approach to this thing. What about this fact whether we can develop a relationship or not? Parameters, we have some hypotheses which we test in regression analysis. That you to understand, and we'll get the answer to your question in I believe next 20 minutes only. Those values will help you to decide whether there is a relationship or not. Whether able to find out the relationship between price and living area or not. Okay, so those parameters will help you. Yeah, good question. It's a very valid question. Suresh, if I talk about beta naught and beta 1, what is the intercept and beta is the line. Let me take back when you're in standard something like this, y is equal to. I'm telling you this thing because many of us forgotten. It is quite obvious that learned it long time back and we didn't use it after that. So it is that you might forget it. So if this is y-axis, vertex, this is axis like this. The intercept is this of this line, origin, where it cuts the y-axis. This is called C. And here in this case, it is your beta naught. And what beta 1? So angle which this line makes with the x-axis angle. To get into trigonometry, but it is tan of the angle this line makes with the x-axis. In business terms, you can call as this is a slope basically. So theta is nothing but your beta 1. Called slope. So but y per unit change in x. So but beta is nothing but y by delta. Change in y by change in x. That's it. Per unit change in x. That's it. Any question now? We have understood so far. I'm asking asking you people whether you have not understood or not. Every 5-10 minutes, so that you can ask me. You can about the speed. Thank you. Okay. Not here. Develop a relationship. Now, relationship before how part. Let's see what we want to do, what we establish. So look at this equation. How many you don't agree with me? If we are able to find out the value of beta naught and beta 1, we are done. The fight here is to find out the values of beta naught and beta 1. Value of beta naught and beta 1 are done. Find out a relationship between price and living area. If you don't agree with me. Great. So all agree with me. So now we know what we are up to. So objective should be very clear. What happens? Sometimes we gerald in the means and forget about the end. That should happen. So what we're doing? We should be clear with our objective. The objective is to find out the values of beta naught and beta 1. And objective, we have to answer Martin's question as well. Martin was very his question: how the relationship exists or not. So we need to get the answers to those questions as well. So start doing something. Let's analyzing something. Okay. Let's look at this relationship. These dots. This schematic diagram yet again. Which you want to create. This would be your beta naught, and it will be change in price per unit change in living area. Should happen. These points should be cluttered very clearly around this line. This should be the ideal scenario. The scenario is at all ideal. So basically what we want for ideal case, we want this point. Let's talk about this point. We want this small should not be that far from this line. It should be on the line. Basically this is which you will make. Don't you? Or value of x. You have a small x. The actual value of y. The value of living area is a small y. This point. This is value. From the value of x is y. At the value of living area, you are getting the price as y. So this is y. But once create the relationship, predict the value of y at this. So the relationship will give you the value and y hat, say y hat. This is the predicted value. So what is this? Something which is troubling you. This is the error part. This is the issue. This we need to fix. Don't you think so? How many of you are not able to understand this point? A very thing. Don't worry. If you are not able to understand, because we'll keep discussing like this. Sure. This value is 2000 and say 500, 2050, any value x. It's for 2050. On 2050, getting the value as 50,001, say. this value, actual value of y. Okay, we have built a relationship between y and x, and after that relationship we are trying to build a straight line, something like this. After building the straight line, what we are planning to do, we are planning to predict the value of price. That's where we start off from. Nice. So value of y will be y hat. That is what I said. So actual value is y hat. This is something with us. This distance, we don't need clue about that. But this distance should be as small as possible. Error, there will be some error. So point as well. For this well, there is some deviation, but for the point, the deviation will be higher. This is the ideal scenario. Ideally, all the points should be on the line, which will be the case. And if things would have been so simple, then we statisticians, we don't have any value. This is something which we are struggling with. Y minus y hat. Let me write here. Y minus y hat. Y actual value. Don't people keep confused with these things and keeping my speed like this. Actually of y this is, and the predicted value of y. This is called residual. Residual. UIAL. Residual. Call it as error as well. Value, this is also termed as error values. So basically, what we do, these error values, or okay, value for all the values for all the sample data we have, analyze it as well, and then mix this function. We learned maxima and minima in differential calculus some time back. We are not from maths background. People, we make this particular thing. We find out the maximum and value of any function. We can find out the minimum and maximum value of function by performing maxima and minima. Unique to the differential calculus as such, but just for the sake of getting of what is happening via screen. So we maxima and minima for a function. Okay. So what we do, find out y minus y hat for all values. all the values, variation, and you will make a minimum for to be able. But minimizing this function will create a problem for us. How can we fix that problem? We have seen this kind of issue before as well. Then you minimizing this function will create a problem for you. Our intentions are good. Our intentions are to fix this error for values and then minimize it. Let's do it very simple. Okay, very simple. That let's find out these error values. These all deviations. These all residuals. Sum up and find out the minimum of it. You will a big challenge in meaning this function. This is a challenge. Think about it. No, it volume of data. Just very closely. Question. Find out this line and the best line basically I should use this word. I use I have to find the best fit line for these all points. In order to find the best fit line, what I said that these distances should be minimum. So I'm planning to sum up these all distances all across and minimize those distances. That is what I want to do. So distances I want to be summed up and then I create a function. But I'm minimizing this function challenge and I want to figure out that challenge. Think about this sum. We show in the past as well. When is the best fit line? Yeah, right. The equal number of yes, yes, Martin, you got the point. I want you people to think about it. Otherwise, it'll be a one-way communication. Let's keep thinking. Let's keep contemplating. If the line is the best fit line, there are equal number of points above the line and equal number of points below the line. Animation would be equal because some positive distance, some negative distances. We are not interested in the line. We are not interested in positive or negative. We are only interested in the distance part. steps, values of those distances, do we all have the solution for that? So that came up with that solution as well. Something we have already done while going to variance and uh, deviation. We face same kind of issue over there as well. So what instead of finding out the rules, we can get rid of those signs by pairing them up like this. One function. This is called a residual sum of squares. Least value of this methodology is also called as least square method. You must have heard about this thing many times. Some call it as O aggression or least square method. Only least square method. So we put the value of this, we minimize it. While minimizing, if you remember, if you don't remember, don't worry about that. While finding out the minima, you find out the first derivative, find out the first derivative, and you equate the first derivative equal to 0. Okay, you create an equation, and from that equation you actually find out the values of b0 and beta 1. I'm not getting because I know people are not comfortable with differential calculus and is not some forward to. That is something which is not required at all. That will on by the tool. You don't need to do it manually as such. So not and beta 1 you will be able to find out by minimizing this function. So the basic element behind linear regression, minimize the squared deviations, you minimize the residual values. That ordinary least square method. With the help of R, how we can do all those things. But I go for that. Let me ask if you have any question. Create that with beta 1. Okay. Why we have square residual? How this is related to beta naught and beta 1? Okay. Some questions coming. What is that we are trying to infer from this data? Okay. And very late. Why square residual? That's which I explained to you. if you are finding out the summation of these values, that will equal to 0. That if I'll find out, we'll find summation of this value that will be equal to 0, and that we are squaring it. From we are trying to find out a relationship between price and living area. We are trying out this line, this shape, a bit price and area. If we are able to find out this relationship, we will be able to predict the value of price for a given area. Do you think so? We'll put the, if this relationship, suppose we'll put the living area, we'll get the value of price. So we have to develop a relationship. To develop a relationship, we mesh the values of beta naught and beta 1. That is something we need to find out. To beta naught and beta 1, I told you, you can minimize this function. That square and then you sum up. So minimizing this function, you will get the values of beta naught and beta 1. That is what you. Question and Sudesh. While developing this function fx, values of beta naught and beta 1 in that function. Can eliminate in this way. Just a minute. So use price values you have, the values, these values you have. Now you find out these are values of price, actual price values. Okay, find out the predicted values of price. With the equation, you have this equation with you. That price equal to B naught B. This is a value. You will put P naught B naught beta 1 and living area. You will put the living area. This the hat. You have the value of y. Use y hat minus y naught. That this equation will involve beta naught and beta 1, and you to values of beta naught and beta 1. Are you wrong? Okay, you enter into the actual calculations. Okay. Here. Yeah. Beta. So these are values of price. You created a relationship. You want to create a relationship between beta between price and x. equal to B1x. This is what creating with the help of regression. What is x here? These okay. Actual value of price and what is the predicted from this equation, that equal to 1 or 2 to make a stand. What will we have in this set naught plus B 1629. This is the actual value of price and predicted value of price. Then what? Difference between predicted and actual. So 1, 6, 8, 5 my whole value. This whole value. Find out the square of it. This up for all the values. What are this function b and beta 1 went after minimum, you'll first derivative of it equal differentiation things, and then use of beta naught and beta 1. Just beat which we need to find out. Beta when beta 1 is again a constant. It is a slope. Values of beta naught and beta 1, which we'll be able to find out by minimizing this equation. If I'm still not able to get it, I can rephrase. I can go for some other method to make you explain it. Okay, but if you're not able to understand, I believe you are clear with this. We minimizing it and then we'll be finding out. Let me run one regression model and then get to the discussion, because it is all about these concepts. Concepts are more important. You will see in one line of code R will multiple values. It will be up to you enter those values. That is more important. So this discussion is more important. That I am asking you to keep asking me questions. If you're in trouble for yourself if you don't know. Okay, take up only one variable living area. And a summary of it. So running this, you would see values here. Too much information are being thrown. They are which to and how to interpret. Uh, Able to run it. Manjuna, Anand. Anybody is not able to run these two lines? Okay, able to run these two lines, and after running these all lines, you would see results. So results 1 by 5. So from this form has been called here. See the residual. So this residual analysis has been done. Residual mean value is this, third quartile for residuals is this, maximum. So sometimes we have to do a lot of analysis for residuals as well. In that case, we this and more of it. So I want to tell you that it is for residuals. Residual, I mean to say value and the comments. I'll simple at the start. The creation find a bit complicated. So leave the things well. What estimates? So these are the values of beta naught and beta 1. Naught and 1. So relationship, anything like this, price is equal to 875.637 plus 80.883 into beta 1. That it has complication which we will be discussing, but this point very much similar like that. Use and they have probability values basically done for t-test. So we have t-test is look up for the hypothesis for which it has been tested. Have been performed here. One test and two t. First test is performed for hypothesis for that beta is equal to 0. This is, and the second t-test has been performed for the null hypothesis beta 1 is equal to 0. So b is equal to 0 or beta naught is equal to 0. What does this mean? If 1 is equal to 0, it simply means that there is no relationship between living area and price. So this hypothesis which you are checking. So the answer to Martin's question now, this is being checked here, that beta is equal to 0. Beta 1 is equal to 0. It's no relationship. B out to be significant here, which is very close to 1. What does anybody interpret it now? 2 p values? Yes, null hypothesis. Significantly affecting the price of house. Yes, both values are, both p values are very less, very close to 0. You see here 3 asterisks. Both are very close to 0. They are very significant. They are very small. If we compare these two values with 0.05, 2 less than 0.05. So reject the null hypothesis. The way that this hypothesis rejected, beta naught is not equal to 0 and beta 1 is not equal to 0. They have a relationship. Is done in relation to check individual independent variables whether they have the relationship between dependent variable or not. That is what is checked in this. We look at this block. This you 2 p values. 2 t values means 2 t tests carried out here. These 2 t tests are what t tests have been carried out for. You need to know null hypothesis for that. The hypothesis for first t test is beta naught is equal to 0 and for second is beta 1 is equal to 0. And if you have multiple variables more than living area, say lot size and other variables as well, you multiple t tests then. So these t tests are performed to check the null hypothesis that the coefficients are equal to 0 or not. Null hypothesis is coefficient is equal to 0. If the coefficient is equal to 0, what does this mean? You have price is equal to plus into x1 variable beta 2 into x2 into x3, something like that. If the coefficient is 0, it simply means that these two, if beta is equal to 0, what does this mean? It means 1 and p don't have relationship. X1 is relationship is if beta 2 is equal to 0. So if how you give value as say 0.8, what would so if the t test for living area comes out to be, p as 8, you have the null hypothesis. accept, yes, you will accept that the coefficient is equal to 0 and there is no relationship, and you will not go for the regression. Multiple variables, you will not include this particular variable called living area. Question. Another test. So the block is done. This is done. So we are done until this. We are done this. Not to look at a test. Statistic. What we doing with the help of this test? Can you know? Here. Elaborate. Actually, this will again give you answer to your question which you asked. Again, look at this p-value to understand what it is doing. You need to know information about the null hypothesis. What null hypothesis which is being tested? What is hypothesis statement? So null hypothesis for this is equal to beta 1, beta 2, beta 3 is equal to beta 4 is equal to beta 5. Whatever number of variables you have, according to that, equal to this hypothesis. So simply let me put here what we are checking here. We are checking the feasibility of the overall model. So test is performed in regression to check feasibility of the overall model, whether the overall model exists or not. Before you check for anything, check for the F check the ANOVA for the p value coming out of ANOVA. Value is not significant. It simply means that the regression relationship does not exist. Coefficients are equal to 0. Simplest, non-dependent variables have any relationship with the dependent variable. Any relationship, model does not exist. P value here comes out to be say 0.9, 0.8, 0.7. Means that you are able to reject the null hypothesis. Means there is no relationship existing between the independent variables and the dependent variables. You need not to analyze the regression output. And now, so we will to understand why running the t test and why we are running the f test here. Okay, Junath, Navjot, Skaria could not understand. Okay. Uh, Repeat in a different way. First, to understand the objective is to find out a relationship between price and living area. If some other variable like say you have lot size. I don't know how these variables are. Yeah. Okay. So you have the variables as well. If you know. So tip is to find out a relationship between price and these independent variables: living area, age, and lot size. But before we develop a relationship, we know if exist any relationship or not. If not existing, then there is a relationship. So how do you check about that? For that, you would look at the equation which you want to derive. So P equal to beta naught into plus at 2 is plus beta 3 into age. Suppose no relationship. If you want to check the overall model, if there is a relationship, I want to check the overall model, then what will beta 1, beta 2, and B? Relationship between price and living area, price and price and age, beta naught, beta 1, beta naught, beta 2, beta 3, all these will be equal to 0. You agree or not? Yeah. All these values should be 0. That will be your null hypothesis. The thing you want to check with the help of F test. Because obvious question which Martin asked when I was discussing about relationship about the result. This is a very obvious question to check. And you are looking for the p-value for that. The p-value for this null hypothesis comes out to be 2.2 e to the power minus 16. It simply means that there is very, very less than 0.5. It 2 less than 0.05. It is very close to 0. So reject this null hypothesis. Able to reject this null hypothesis, it simply means that you are saying that the relationship is feasible. You will be able to derive the coefficients. They are non-zero numbers. About F test. The T test performed for the overall model. Now tests are performed for individual variables. The null hypothesis will be beta 2 is equal to 0. The null hypothesis is 0. You got the p-value. P-value is coming out to be 0.532. What will you do? This t is performed to hypothesis beta naught is equal beta 2 is equal to 0. Is what would you do? What would be action? Cut this p value 0.534. So if we would accept the null hypothesis, so will Luke Hill, and accepting the null hypothesis means you would consider beta 2 is equal to 0. If beta 2 would be equal to 0, it simply means this term is the regression equation. It means that there is no relationship between price and living, price and lot size. And here, yes, Adit. So lot size is being out of analysis. Information you asked for this thing. I'm telling you this thing. Lot size and price were having very low correlation. So you can relate it here with that. But again, is what of mark? That is thing very difficult for you to find out. So this and living lot size and price was a correlation among around around 0.15, I believe. So 0.5 correlation, yeah, 0.1. Price and age had correlation around 30%, 35%, something like that. Sorry, 0.3. It was, yes. It is being considered. So look at we actually the correlation coefficient values. Yes, the coefficient affects that in your because I have drawn here these all things. So the chat window open as well. So you are able to understand why we are running t-test and f-test. So t-test run to the individual variables, whether they have relationship or not, and test is run for the overall model. Any question? Explain more on f-test. Don't worry. A lot of things are yet to come, but whatever I have explained, so I understand that. Test p value comes out to be more than 0.5. What all variables are significant? Value for f test comes to be more than 0.5. We will not look at anything in addition then. It's that the regression model is not feasible. I used it many a times. Example, to make it very simple for you, I'm into marketing, so my work was to increase people's performance. tips and all. So it was one of uh, the areas which we used to look at. So analysis how the sales of different sales people depend on number of calls, depend on the experience, on the area where they are working, the product they are selling. So things we used to analyze. This line equation is used for predicting only. Okay. I will take a break. Give me 2 more minutes. Or let's break here, and I will be discussing the case uh, uh, I experienced. It's a very interesting case. Let me discuss that case with you after the break. Okay. This kind of analysis for AP as well for their marketing operations in India. I'll discuss our break. So you after 10 minutes. Let's not make it more that some very interesting stuff is coming up. Let's thank you. Every back. Okay, let's get into discussion again. We were discussing about F test. You were discussing about T test. And then with one example. Uh, let me do that example maybe after the discussion of R square. Okay, after discussion of R square, let's discuss that point. And we can complete the whole of let's add all numbers and we'll discuss about the business. Hope all are clear with F and T test. Now, so get some R squared value and its adjusted R squared value. Let's discuss about that. Yeah. Back to this diagram. So take back to this diagram and let me remind you what we did in equation as well. In that problem as well, I asked you to this data and get me the estimated price of near New York bulb. This I told you not to consider any variable, not any other independent variable, only consider price. Basically playing around with the mean value of price in that case. Value of price is suppose like this. This is the price. This is Y bar. With this value only, Y. Use some number for some estimation. So let's get into the shoes of a person who wants to price the price of different houses near New York. If he only knows about the prices of a few houses, like he have around 1,000 houses. If I only know about prices of these houses, any other thing, I have around 1,047 houses are given. If I only know about the prices, I don't know about any other thing, I would which we basically will use and estimate for the price using the mean of sample mean basically. We'll find sample mean. So we will add and subtract the values. If you remember, we did estimation x plus minus into s divided by root n. Okay, so we actually did that using the sample mean. Yes, yeah. That did when we had only price variable. Had little information, and from little information we estimated for the price. So if somebody will ask me what will be the price of what is the price of house near New York, so mention number. We will in that interval that the price will lie between this value. That is where you will go about. Okay, so that, but here in this particular case you have other variables as well, so you can now obtain a better understanding of the price, obtain a better value of the price. You are not estimating only. So estimation is uh, uh, prediction is always better than estimation. Predict the values if you know. If somebody will ask you simple that what will be the price of this house, you will ask him what is the living area. Can you tell me about the living area? How many bathrooms it has? How many bedrooms it has? What is the lot size and the age? And whether it has a fireplace or not? Can you give me this information? If you are able to give me this information, I can tell you what is of that house. That is when you don't have any variable. So the mean value. What you are trying to do, you are trying to find out the variation in y. You are trying to explain the variation in price with the help of these variables. So here we have only living area. So with the help of living area variable, you are trying to find out the variation in y. You are trying to gauge the variation in y. You are trying to gauge the variation in the price value with the help of living area. This is what you are actually doing. So let me tell you a few things here. D2 lengths. What this y not have any independent variable. You with the help of y bar. Amount. Okay, thank you. This is called deviation. Able to explain with the help of regression. So you are able to do until find out the sample mean, and then from sample mean you are estimating. After running the regression model, you are able to explain this much. The total variation is this much. much. From this you are able to explain with help of regression. What about this one? How many to understand this part? Explain deviation. So basically, you have mean value of y. You this sample of this price. Simple mean of y is around 35,000. 3,000. This y is y bar. Times the total deviation is y minus y bar. Our deviation, you're able to explain point y hat minus y bar. So you are able to explain with the help of regression equation, because regression equation will give you this value. So y hat minus y bar is you are able to find out even after regression. Yes, you are actually meaning it, but you are not. You have no idea about this. This is thing which is unexplained. This is the residual part. So this is unexplained variation or an deviation, whatever you want to say. Unexplained variation, you have this. So total deviation is y bar minus y. Out of y has y bar is called explained variation, and y minus hat is your unexplained variation. Put it somewhere. So actual value minus y bar. This is total deviation. Total deviation. This is y hat is something which is residual, which is as well in the regression. This unexplained regression as well. Y hat minus y bar. This is with that of regression. Total deviation y minus y bar would be equal to minus y hat, which is unexplained, and hat minus y bar, which is explained. Please, if you have not understood it, it is a very important point. The definition of R square. Okay. If square of it, and we'll do some mathematical manipulation and assumptions as well, you find out the sum of square of this, I say y minus y bar, this will equal to hat square y at y bar square. Called ST 2 of a square. This is called E m of a square called R sum of a square. I'll reiterate. This is total sum of a square SST that would be equal to C S square plus R reduction sum of a square. Okay. Then if you have, you can ask me. Regression, it is explained with the regression. Detail has been explained big time when we were discussing about the residual part. You see here, the whole premise of OLS y minus y bar, sorry, y hat is residual. You want this point y, the actual point, this line only. So y minus y hat is the error. This is the explained part. This is the residual to find out. So where these values, and then you sum up these values for to find out the square of residual values to get the values of beta naught and beta 1. Okay. Sum of errors as well. Sum of dual values or sum of errors. Sum of squares of error. Navjot, you got it? Question? Okay. What you actually want? What you want is what do you want to kill? What I will part. This then from this we are line relationship between x and y. When were unknown to and beta 1, we looked at the whole part, the part, then we understood what is beta, what one beta naught is the intercept, beta 1 is slope, with the actual value and predicted value, what is the difference between actual value and predicted value. If we sum up all the values, the number is 0. In this way, we first of all find out the square of all these values and then we sum up the noise, so minimize it, and finally I'm discussing about squares. Has been explained by the regression, how much has not been explained by the regression, the variant part. You got that? There's a graph. What? Yeah, that. But you might not be able to. Some of you might not be able to see these things as this is 2006 version, 2000 version. So what I have drawn, this is available in your Excel, this raw facility. Otherwise, you might not be able to see this. No problem. You must have been taking the notes. I have not written anything which you notes of. Very late about. Yes, yeah. Okay. Okay. If cat you are in this way, the total square, if it is confined in this box, this is the total sum of a square. If it is confined in a box, you would see SSE and start as SSR. For regression model, SB more or SSR should be more. What I see, it is residual sum of a square, standard sum of a square. So the error or error should be more, or radius sum of the square should be more. It's about that. You can look at this diagram again. What do you want to be more or this distance to be more? You want more of y to be explained with the help of this independent variable, and you want this value to be as small as possible. That's the whole premise. You want this error value, this residual value to be as small as possible, and you want to be as big as possible. You want error part. This is a sum of squares of error. This is a square of error. This is a part. You want this to be as small as possible. Regression model. Premise of regression. You want residual part to be as small as possible. You want RSC to be as small as possible. You want maximum variation to be explained with the help of the independent variables. You want this R to be as big as possible. Yes, Nikhil, you are right. So acceleration should be possible, and as small as possible. There should be no confusion in that. So basically to say that this proportion SR T, this large as possible. So our total vision regression should be able to explain more of it. Called R. So proportion of deviation with the help of regression. Very simple definition it has. A proportion of the variation in y that explained by the regression relationship of y with x. So in data sets in different industries, you have different cutoff values of R square, but generally, if R square is more than 75%, you consider that regression model to be very good. To be able to explain more than of the variation in the dependent variable. How many questions in this? This is a favorite question of any interviewer and stuff as well. Some people are not able to explain it properly. Because explained properly, they should be high. It should be high. What it actually represents, you need to point, and I believe explain. So if you have any question in this, please ask me. Because if somebody will talk about regression, will definitely be a question to ask. Discussion forward now. All of you are able to understand this point. And if you have any question, you can always talk to me because we are saying R square only right now. If you get this R square value in this particular case, you to be 63%. which is a good number. And let me show you what value of r square we have if we have only living area. We have only. So if including more variables, you see the square is increasing. And it should decrease, no? It should increase. If you're including the pertinent variables, including those factors which are affecting, which are responsible for the variation in the price, if you include those variables, and you'd all be able to explain it better. Okay, keep including the number of variables. If you'll keep increasing the number of variables in the regression model, the value of this proportion, the value of r square, will keep increasing. Point. What happens? Value of r square becomes big. Huge. Problem of overfitting in that case. So only when you are only increasing the number of variables. So whatever variable you increase, there will be some increase in r square value. That must see. To the problem of over, that is called adjusted r square. Let me introduce you with another term called adjusted r square. It takes into the account of the number of variables as well. So there's the average value. So drag you into the calculation again, but you should take this. You should understand it in this way, that when r is divided by a degrees of freedom, and again is divided by the freedom, it becomes adjusted r square. R square and r square. See, in most of the scenarios to each other. And they'll see the value of adjusted r square and r square, these values are very close to each other. There is a big difference between the values of adjusted r square and r square. You should adjusted r square, which is a better of variation in by independent variables. You look two values, you come up with. Some people will have the argument like, why at all we are learning r square? We should only adjust r square, then we should know value of adjusted r square. For those people, you understand whether you have an issue of over not. So under this issue, you need to look at both the views. If there's a big difference, then there is a problem of overfitting. We have two degrees of freedom. Degrees of freedom, corresponding degrees of freedom for SSR and SST. One well taken. Please come again. Elaborate question, Nikhil. Okay. R squared, as I mentioned, and more about variables, how these variables are creating problem, and why you are not accounting for all the variables. Why are you going for mean values? I'll talk about that more in next 5 to 10 minutes. But before that, let me tell you, increase the number of variables in your model. Keep increasing. Okay. Any until you of overfitting. So we'll see the problem of overfitting if we'll keep increasing the number of variables. We're looking at the adjusted R square. So we'll increase the number of variables and R square as well as R square. Both will increase. But in the redundant variables, R is, but R square will not increase because here you are dividing the new as well as denominator by the degrees of freedom. So the number of variables will be taken into account. Okay. So understand what is R square. Square, let me tell you, it is also called as coefficient of determination. So part of it, R is also called as coefficient of determination. Will become adjusted coefficient of determination. So here, so it can also be called as multiple coefficient of determination. Adjusted R squared, adjusted multiple coefficient of determination. Okay. So while discussing about the variables, the number of variables we are increasing, and whether the variables are redundant, so those kind of issues we have started discussing. Leave you with an issue which we face while performing regression analysis. The type of multicollinearity I want you to get familiar with which if you are in the regression, it will create a problem for you. So you can avoid this issue of multicollinearity. Any problem, whatever, until this, because the number of increasing, it would not be a information overflow. Until this point, please ask me before linearity. You should be very clear with R square value. That's this concept of multicollinearity. Okay. Ananta Krishna, it's a good question which will be answered whilst discussion of multicollinearity. We treating this redundancy of the variables. Call out some questions as good questions, because if asking those questions, it simply means that you are on track, you are very with me, because very obvious questions I am following, you are following that structure, your mind is also that structure. It simply means that. So just because of that I mentioned these things. So before I get into multicollinearity, I will quickly explain R square, what R square is. That the total variation in is SST, which is, so a lot of time, like I've explained it multiple times. So total variation is like y minus y bar. So y bar was the mean of price value, and y the actual price value. So two total value is the total deviation, is the total variation. Which out this total deviation, total variation, that y hat minus y bar, something which has explained by the regression line. This is the regression line which explained this total variation, total deviation. But this is something which we are not able to find out with the help of regression. Well, so that is I have shown here. The total equal to the unexplained plus explained. Something which is able to explain with the help of regression, y hat minus y bar. And there's something which is a residual part, which is the error part, which you are not able to explain. Mathematically, you'll square these all values, you will find total sum square equal to f square, which is unexplained deviation, unexplained variation, plus regression sum of square, which is explained with the help of regression. I told you, if you will draw a box, the area of the box you can is SST to square. Some part will be SSC and some part will be SSR. For very good regression model, the portion of the variation explained by the regression SSR should be high. By SST should be as high as possible. That is called R square. It is also termed as coefficient of determination. The value should be as high as possible. Since if you increase number of variables, the increase there will be an increase in R square value. At some point, R will reach overfitted model, which will present an overfitted model. So here we look at the value of adjusted R square, which is nothing but as R square. The different numerator and denominator both are divided by the corresponding degree of freedoms. The difference. Okay. Means you are increasing the number of variables. The variables are redundant. A square value is increasing. You reached an square value, say 95%, but actually explained variation is not like that. You look at adjusted R square. The adjusted R square value might be only 70%. Therefore, fitting that you have to look for. You got Jyot? Now that we understood what is R square, what is the problem of multicollinearity? These are redundant. You, uh, dependent variables. What do I mean by that? I mean by that. You have people, or these people you have for different quarters. You have for different quarters here. You have past year results. 1, 2, 3, 4. Now sales people you have your CTC revenues, and want to see people and CTC are related to revenue. So basically, I want to find out the relationship between the revenue and number of people and CTC, something like that. Beta naught REV, B naught plus B CTC plus B into number of people. I'm just people by hash. This relationship we want to develop. So the businessman, decision maker, you know that he cost to company and it is endorsed and it's about the fees you pay to sales people, and number of sales people is about the skill you have deployed to different deals and get you the revenue numbers. So know as a businessman, but what the tool are? What about the mathematics? For tool, they are tool to understand your business. They will treat these two as numbers, and tool see these two as redundant variables. These two variables are no different. They are same. Why? Can you tell me? Can you let me know your thoughts on that? So we'll find out a relationship between revenue and these independent variables, number of salespeople and CTC. Businessman, for you as a decision maker, you understand what is number of salespeople and what is CTC. But for tool, these two variables are redundant. Tool to tell you that these two variables are same. These two variables, take up one of these. To understand the difference. Salespeople it is. CTC will be different for different salesmen. Data of different quarters. Numeric values and it is a continuous data, it's okay. But why these two are so, why tool is calling us so similar? I'll try. Let me one more variable. Say variable I'm taking here. This variable as suppose multiplied by CTC. You multiply to revenue to get the CTC. How do you distribute the CTCs to go for expenses? Another variable, and you will have the same problem because it will find the number same. I'll tell you. Look at the correlation coefficient between salespeople and CTC. The correlation coefficient between these variables will be very high. So the correlation coefficient comes out to be 8.5, 80%. Simply means that number of salespeople and CTC both are highly correlated. People are increasing, CTC will also increase. It is quite obvious. Different people will have different CTCs, but for different quarters you will have same proportion of people. Proportion also be distributed. Will increase with the increase of sales people, and the association will be strong. It comes out to be 0.5. Tell you, and the more you did in that case, that variables are same variables. Why are you taking them separately? It will create problem for you. Same variable, because both are so correlated among themselves, they create the same kind of impact on the revenue. On the revenue, the variation. So basically, why are you developing this model? We all understand this thing now. We want to variation in revenue variables. So we are creating the same kind of variation in the revenue. So separately, we have device methodology. Otherwise, it will give me the wrong information. How many understand this point? I got it. Could not understand. This is not something we are assuming. This actually happens. thing I'll reiterate, but in a different. Let me read it. When you have independent variables with high correlation among themselves, then actually they are redundant variables, and they create the same kind of impact on the revenue on the independent variable. So the variation produced by CTC on revenue will the variation produced by number of sales people on the revenue. So them in model will create the problem in the model, the multi-collinearity in the model. So what do in them separately, we or we can get rid of them. We can only take CTC, take number of salespeople and CTC both together. We can only take CTC. We can only take salespeople, number of salespeople. Or we can create another variable for variable like CTC employee, number of people. This variable we can generate a new variable altogether, and then we can find out the relationship between revenue and this new variable. We can do study of multicollinearity. Dive abundant variable in that case. Yes, Ananta. However, there is high correlation. Dependent variables are said to be redundant variables. We can create the same variation on the dependent variable. Point 0.25% is 0.25% effect. .25. The difference between a number of salespeople and CTC is 0.85. It is the effect of these two variables on revenue. We are for the variable CTC by number of salespeople, another variable altogether. How will that impact? That actually create any problem in the model? Tell. Point is the correlation. So it is only the indicator of association, of the degree of association between the two variables. So if this high correlation, we'll get to know that there is a problem of multicollinearity, and then we are sorting that issue out. We are solving that issue by finding out a new variable, by doing a new variable CTC by number of sales people. Take this new variable now, and now we are taking this variable into our model. You're not able to understand. So in this, we have found out this proportion. In situations, you might have to go for some other relationship. Okay, so, Ananta, if you have any other question, anybody, you can ask me before I go in you how you figure out the multicollinearity issue. Okay, so now understand what is multicollinearity and how it affects the model overall. Get into further discussion. So talk about this. Talk about another. But is it necessary to have a new independent variable in the multicollinearity? Necessary. You can take out one variable as well. Like, I'll give you another example. These two variables, CTC and F into CTC. So in the case, you are only multiplying with one factor to CTC. There will be a big correlation between these two variables, CTC and F into CTC, CTC and X. There will be a correlation of around 9%. In the case, you can take out one variable. You can take out either CTC or you can take out either X. To get a new independent variable when we are not able to take out any variable, when we are not able to get rid of any variable. We take up both the variables into the consideration. So you want a relationship in which you want to see the things. You want to see number of salespeople as well as CTC. So in scenario, you are not able to get rid of any of these two variables. So you are combining both the variables into one variable. We'll look at this question now. Naught plus beta 1 into CTC by hash. Okay. Basically, if you see what is multicollinearity, whenever I have independent variables very correlated among themselves, so the relationship between independent variable, then it's a problem. They were assumed to be independent of each other, but problems. Let me do further in that. Understand it better, and I want your attention here as well for 3 more minutes. It is a very important discussion, otherwise you will keep getting confused because multiple R squared values here either, and attention here for 5 to 10 minutes. It will your so have x1, x2, x3, x4, these 4 independent variables. With the help of these independent variables, you are predicting for y. Actually have an equation like this: y is equal to b plus x1 plus beta 2 x2 beta 3 x3, something like that. You have this equation. You want to check for the multicollinearity. If for the multicollinearity, you have to forget about y. Multicollinearity multicollinearity issue has nothing to do with the dependent variable. So for y, and now let's discuss about x1, x2, x4. It here again, because after the whole explanation, if you'll ask me to repeat, you actually waste your own time. So actually take you through these basic things, and I keep see my way of teaching. I repeat one statement like 10 times. I don't want to repeat the things all over again after 10 minutes. So please look into this. Focus here. Otherwise, get confused. I'll ask this. I pay attention here. So here, we were realizing the probability collinearity. For we are taking up the case where y is the dependent variable and you have x1, x2, x3, and x4 as dependent variable. You are developing a regression model like y is equal to beta naught plus beta 1 x1, beta 2 x2, beta 3 x3. Now we are discussing the issue of multicollinearity, which has nothing to do with the dependent variable. I never discussed anything about the dependent variable. It's all with independent variables. You say issue with the independent variables. The issue is among independent variables. So we will forget about dependent variable and we will not discuss about only the independent variable. Now dependent variables x1, x2, x3, and x4. What we now will pick up x1. Find out if there is a problem of multicollinearity with x1 or not. With the problem of multicollinearity with x1 or not, what we do, we will make x1 as dependent variable and dependent variables as independent variables only, and we run a regression model. Regression model now, and with that regression model, we'll find out the value of r square. R square value will find out 1 minus r square. This tolerance. From 1 minus r square, we'll find out 1 divided by 1 minus r square. This is called as F of interviewer. VIF, variance inflation factor. This is variance inflation factor. Doing it again, and I some of you ask me again to do. It is variance inflation factor. Inflation factor. You were pretty much focused into this. A good regression model, you don't want problem of multicollinearity. To be high or VIF should be less. Tell me what is VIF? What does VIF tell you? Explain to you everything how we calculate VIF. Good model. I repeat it again. Think, don't jump into the conclusion, jump into the answer. For a good model, you don't want the problem of multicollinearity. High or VIF should be low. low. VIF should be high or low. I'm getting few responses. 1, 3, 4. No, low. Again, sensory effect. Some person says low, everybody follows that. Then somebody says high. Now I have too many highs now. Okay. So it's understood it properly. It should not be a big problem for you. Let's do it together. Okay. Let's stand it together. Do you want a good regression model? Value should be high or low. There, I'm talking about. Soumya, Navjot, and Lokesh, it should be high. R square high here in this case simply means that x2, x3, and x4 are able to explain the deviation in x1. It's simply a problem of multicollinearity. High square value means multicollinearity. Value should be low. Here is case. We are only with the independent variables. You are again confusing yourself. Are you getting? Lokesh, Navjot, and Soumya. Higher value will indicate high correlation among the independent variables. Square will only indicate that is being able to explained by the independent variables, rest of the independent variables. It should be as low as possible. So one be as possible. Here should be as low as possible. So we leave Nikhil and Sweet was right. Right. So there, yeah. Good. How many understand it? Do I say a lot about repetition, but again, I'm here only. If you want me to repeat, I can repeat. If you want me to explain a particular thing, that will be actually great. If you specify a particular thing that yes, I could not understand this point, easier for me to explain. Or else me to go all over again, I can go for that. Tell me, how many of you understand? Okay. So, okay. So we have understood 1 minus r square will be tolerance. Very simple it is. I'll not complicate it. 1 square is tolerance. It which gives you the percentage, the proportion which you can tolerate. Percentage here which you tolerate, which explained by the x3 and x4 variables. In x1 being x by rest of the independent variables x2, x3, and x4, which can't tolerate, which is creating the problem of multicollinearity. and there is the tolerance which is the you can take along with you. Yes, yes. And is the opposite. It is the reciprocal of tolerance, 1 minus 1 divided by 1 minus r square, which is concentration factor. Okay. So VIF, if you calculate here, okay, install a package here called CAS. I believe helped you install this package in the second class. Install this package and then you need to call from the library to use function VIF. Getting no correlation among the independent variables will produce a good model. Yes, Nagesh, you are right. Uh, two ways. So you should have at least two variables to actually calculate it. Please these three together to actually get the values of VIF and get for the go for further discussion. Are you able to get the values of VIF? It AR. So let me help you with that. No problem. Take some time. A lot of functions in that. So then let me know. I have yet to a few more things in regression, but I will take regression and will explain you a few more things. I use some time to absorb these all concepts, and I'll come back into regression again. Many to do to on good. So we have understood many concepts in regression. Coming back to regression, like to come back to R programming as well. More things, some very good things. So there's yet to come. So regression as well, I'll be coming again. So very important things which are left, we have to discuss. Logistic regression as well, I have to discuss with you. But before I discuss further, I will be giving you a say one more session, maybe session. I'll be coming back to regression. So, but in the meantime, let's discuss another concept. Just give some uh, very important concept. So, clustering, cluster analysis. But go through all these concepts after session. Any more sessions left? So concepts so that I don't have to all again on some concepts for some tools for some topics. Save your time only. Okay. Discuss about classes. I discussed about it in the first class. What analysis mean and how it is helpful in business situations. Come back to that discussion. This is a technique. Which is used in many forays. It is in medical sciences. It is used in marketing. It is used in industry a lot. Also used in stock exchange market. Okay, it does is something we need to understand. To understand what it does, we need to understand a concept of supervised and unsupervised learning. So, how to understand what is an unsupervised learning and what is supervised learning? Anybody from you? If anybody understands what is supervised and what is unsupervised learning? Okay. So unsupervised. Say that our class is not unsupervised. I'm here. You are see negating my existence. So your response is self-paced is supervised. Yes, unsupervised. Yes, such is unsupervised. Okay. Yeah. Thanks for your responses. Uh, let's discuss what is unsupervised and what is supervised. It's an important concept which I'm discussing at the end of this session. We have 20 minutes to go with, so let's get a discussion. I stand. These are last 20 minutes of our 4 hours class. Let's focus on the discussion. I'll not ask you to do any calculation in this time. Oh, so in this concept, to understand the human behavior, we regularly do day-to-day activities. What is day-to-day activities? And see some common. And we don't do anything abuse. We only categorize. That is do. The whole. Whenever we analyze anything, whenever we look at anybody, whenever we see anything, we all categorize. Our mind is to categorize. What is it? See, look at anybody, whenever person. What we do by base, our starts searching for the similar kind of person. Some statement right in front of him that I have seen you somewhere. Your face is similar to that person. And if you don't statement in front, uh, you will think about that thing. That his face is similar to that person. He looks an Indian guy. He looks like an American. He looks like a so which your mind is actually accustomed to do every time you do anything. Whenever you see any new thing, always try to compare with your previous knowledge, with your previous data which you have stored in your mind. You always compare and then you put the things into different brackets. This is what you do regularly. Don't you agree with me? So this we always keep doing. This is our human nature. Why this takes machine learning two parts. Supervised learning. So we always clusters. If there is a possibility, and see this thing many a times in our life, we look at some object and we look at that object for the first time. we are able to relate that with our past history, and at that time we get surprised. Say that I've not seen this before. See, this is a strange thing. You always think, see, this is something very strange. I've seen this before. Back out. Because that which is a change brings surprises. That brings surprise to you. That able to relate with anything which you have seen in the past. So that this is something strange. This is something new. You that again bucket that up into strange. Okay. Suppose see two things in a go, and in those things as well, you will again try to find the similarity. I'll show how. Different objects like this. These was new for you. Or interested in relate these objects from you get these objects. What you do, this is our behavior. This is quite natural. What we'll do, we try to find out the similarity between these. Again, our mind will start similar objects into different buckets. Bucketization is something with human which we always keep doing. At our discussion again, if you'll go to our whole discussion, what we have learned. Human is what is embedded in our mind, what my mind is accustomed to every time is bucketization. It gets objects in two ways. Is to compare the new object past objects from its previous understanding, where, and then it will again bucket the new object into which it has seen in the past. Thing. Second way of bucketization you have seen here. You have few objects. With those objects, you will see some similarity, and those objects you will bucket together. Two types of bucketing. In first way, you bucket already created buckets. You create a new object, a new person into buckets. And usually creating the buckets called unsupervised learning, and the first way is called supervised learning. So this bucketing is unsupervised learning. And I'm a bit more. Don't worry if you're not able to follow it completely. But maybe because not able to. Supervised learning, I'll give you. You are analyzing the fraud data. You are a credit card company and you are analyzing the fraud data. from previous experience, and I must have discussed this thing with you, I believe, in the first class, but I'll again come back to that. And I'm intentionally taking up the same example as well. I have examples to come up with, but let me discuss this. So you have different profiles here of the past customers. 1, 2, 3 different customers you have. You have their address, you have there you have 3 values. You have the information about their fraud, whether they committed the fraud or not, whether they faulted or not. 0, 1, 0, 0. So you have this information. Okay. What do you got these all like this? Sorry. These all like this. Oh, person coming. Customer initiative, whether this person belongs to this group or this group. So mind actually categorize how find out the similarity. What you will do, you will look at the past data. Your mind also does the same thing. You look at past data, you have to match the address, income, and according to these 3 factors, you categorize this either into pink, into green category. For that relationship between these and fraud, we will develop a relationship. So this you are doing, you are actually relationship here is called as objective function with past data. So from past data you compare this trend. So the object you are comparing with the existing clusters, with the existing buckets, and you are doing it in any of these. This is called as learning. What you do, you look at objects, then you try to find out the similarity between the objects. You don't think about the past, and then clubbing objects into different this is what you do in supervised learning. How many of you are not able to understand? Wonderful. Understand? Please feel free. I have and I'll not be discussing anything new. So area about grouping. The bit past information, use relationship, using objective function, then it is a supervised learning. If you have any past information, you are only looking at the behavior, only looking at the price, only looking at the data. Existing is called unsupervised learning. Yes. So when you think about your mind, how it categorize is very much like when you categorize uh, strange objects. Suppose you are made 100 strange objects you have not seen before. What you will do? You might again try to bucketize those new strange objects into buckets. Nikhil, right? Classes is an example of unsupervised learning. Uh, if you go to regression, we'll be learning logic regression. That is an example of supervised learning. We're learning many supervised learning techniques. 2 sessions I'll be dedicating to supervised and unsupervised learning concepts. And you're able to understand those concepts very well when you will go through the past uh, classes, when you are concepts. So, please go through the past concepts and go better. Okay. Okay. Any further? I'm off with cluster analysis in the next class. Discussing about addition rules, and coming back to regression, I'll be discussing about logistic regression, a few steps of supervised learning. Okay. So this plan is. In the last class, I'll be discussing about series analysis to some extent. Any question? Yeah, yeah. About the basket analysis. Okay. See you tomorrow. But for next 2 days, in the coming week, you'll have to toil hard.